So from this slide, I'm gonna explain a little bit about the different thermomechanical simulation methods for laser powder bed fusion process simulation. And I'm gonna explain a little bit about the concept of inherent stream method and the uh, uh, background of the inherent stream method that we are gonna use in this tutorial and for the two workshops. And after that, we continue the tutorial and the presentation mm, by starting the uh, micron scale and macro scale model. So, uh, today, high fidelity validated thermomechanical simulation can be effectively used to accurately and efficiently predict the temperature distribution and residual stress and deformation in the metal additive manufacturing process. Since the metal additive manufacturing is affected by several process parameters. So in the industry, investigating the effect of each process parameters on the final distortion is not uh, computationally, and that's much expensive to investigate all the contributing factor experimentally. So the different thermomechanical simulation have been introduced that can be employed for uh, investigating the process parameters. Totally, there are two uh, different approaches for the numerical method. The one is the detailed thermomechanical simulation, and the other one is the inherent strain method. The first one is divided into fully coupled and partially coupled analysis, and according to this method, we can obtain more accurate results, but in terms of the computational of time, the simulation time, it's not computationally efficient, specifically for the complicated geometry parts. So, but take a look at to these two flow chart. We can see the algorithm of fully coupled thermomechanical simulation and partially coupled thermomechanical simulation. In the fully coupled method, it is characterized by the mechanical evaluation after each phase of uh, thermal analysis step. It means that the geometry is modified at each time step, and the displacement will affect on the temperature distribution. So this is down for each scan track and for each layer in the laser powder bed fusion until the end of the whole process. But the second method is the partially coupled thermomechanical simulation. In this method, firstly, a transient heat transfer analysis is performed and the temperature distribution is extracted. And it's going to be applied as a temperature field on a quasi-static mechanical analysis. So after that, we can predict visual stress and deformation. So the transient heat transfer analysis and quasi-static mechanical analysis are independent, and it is done separately in two different steps. But the other method is the inherent strain methodology, which can obtain the less accurate results, and on the other hand, uh, it has low computational cost, and we can have a very fast prediction. In other words, we can say to overcome the huge computational burden associated with the LPBF process caused by the tiny laser spot size and thousands of physical layers in micron scale, the inherent strain method can be an effective and viable method to be employed in the uh, LPBF process simulation. In this method, first of all, on a micron scale model, a detailed thermomechanical simulation is performed and the plastic strain tensor are extracted, and then these plastic strain tensor are applied to a mechanical model in a layer by layer, and the final distortion and residual stresses are predicted.